Welcome to Mirantis Lab's Tech Talk, where we discuss everything cloud native, use cases, and tutorials for everybody's education and learning. This week, we will be talking about CI/CD with Kubernetes and how it differs from traditional CI/CD. My name is Kevin Ung. I'm a solutions architect at Mirantis. And a little bit about me. My work is really to help folks uncover issues and guide them to a solution. For the past decade, I've helped multiple Fortune 500 companies achieve their business goals by improving the people, process, and technologies in development, requirements management, or continuous integration, testing, deployment, and monitoring, either on-prem or in the cloud. A few things we want to achieve in today's Tech Talk is the following. One, set a foundation for what CI/CD is, because there are multiple definitions out there, and CI/CD, the acronym, can be open for interpretation. So let's set a firm baseline before we start. Two, for those of you already practicing CI/CD, how does working with Kubernetes differ from traditional non-containerized deployments? And three, how to achieve different deployment strategies with Kubernetes, and also why we want to use them, a bit of pros and cons, so that you have more information in your decisions. Before we start diving into details though, let's remind ourselves why we want to implement CI/CD in the first place. This quote you're seeing on the screen is from the Phoenix project, which is now almost standard reading for anyone who practice DevOps. Our ultimate goal, whether we're on the business side or on the technology side, is to provide value. And value is only achieved when our ideas reach the end customer and we start observing the results. So, as the quote says, unless value is being generated, it's merely work in progress. But it's very easy for us to focus purely on the tactical day-to-day activities, especially with the amount of requirements to deliver and the different fires to put out. So it's always very important to remind ourselves from time to time what we want to achieve, which is putting code to production and providing value. And CI/CD allows us to reduce the friction of converting a business idea to business value by providing a few core capabilities. First of all, the consistency of the deployment process, which reduces manual errors. Now most, if not all of us, would have come across the deployment handbook of various forms, either from a Word document to our favorite multi-tab spreadsheet. And as good as we are, humans really were not built to handle repetitive, monotonous tasks very well. So it's inevitable mistakes will happen in the process. With automation and consistency in CI/CD, that all goes away because the machine does exactly what is defined, no more, no less. So this way, the little errors that we produce when we're going through this multi-tab spreadsheet is reduced. We take that out of the equation. Now, secondly, every change triggers instant feedback, enabling continuous improvement. One of our sales directors here at Mirantis always likes to say, perfect is the enemy of good. And I think it's a pretty good phrase because it's much more important to iterate and improve rather than to get it right the first time. Because there is that chance that by the time you get that feature to the customer, it may be too late. Or even worse, it's not what the customer is really looking for in the first place. So being able to find out the feedback from the customers and then really quickly improve on that or quickly act on that is much more important than to do a big bang delivery. Third of all, it reduces risk through the use of smaller batches of deployment. Because now what you have is you got a smaller code essentially change that you're putting into your production environment and your releases. So A, rollback is going to be easier, and B, finding the root cause of any issues that may come up is also going to be a lot easier because now you're only pushing a few features rather than multiple features, which is going to be much harder to sift through and try to triage. Last but not least, there's the faster delivery of features. Of course, we need to couple this with release methodologies, but if the application is architected to support the deployment, there's much less code to update. Therefore, the time to deployment is much quicker because the file is physically smaller. So let's start with a brief background on the differences between continuous integration and continuous deployment. Now, continuous integration is the practice of merging all developers' work into a shared mainline through an automated build with the intention of detecting integration errors as quickly as possible. Some of the important activities here is the different tests after code is checked in and built. Now, as you can see on the screen over here, after your code is complete, perhaps you go through some unit tests to make sure the functionality is correct. Then you go through your integration tests to ensure that whatever you built is actually going to be able to work with the other components. And then finally, your user acceptance tests. And by that time, you'll always have a built version of your code that is ready to be deployed. Now, when you put the CD side of things into perspective, there is I would say, not a disagreement, but more of a interpretation of what CD actually means, right? Some say it's continuous delivery, some say it's continuous deployment. Let's say it's probably both, and it really it depends on what you're doing after you've got that artifact ready. So with continuous delivery and continuous deployment, we take it a step further and we deploy all of the code changes to the staging environment or the production environment after passing all the tests after the build stage. And the difference between continuous delivery and continuous deployment, I guess in my mind, is that continuous delivery may adopt a manual deployment process or have some sort of approval gate before deploying to production, whereas continuous deployment goes straight to production. Now, one important aspect to consider when practicing CI/CD is how the users will be affected by the software changes. The deploying application is a technical decision to determine whether a version of the software is installed in a production environment. Which server it's going on to, what version are you putting onto which servers. But making that version available to the end customer is a business decision. So practicing continuous deployment does not necessarily mean that any new features developed is put in front of the end customers right away. That would be continuous release. So it's very important when you're setting up your process to decouple the release from the deployment. Now, through various deployment strategies that we will discuss later to support this, you now then have the flexibility of controlling when you want to release features to your customer and where. Now, when talking about CI/CD, it's very common that we hear the term CI/CD and the pipeline together. So I thought I should cover that as well. Now, what is a pipeline? The pipeline is the automation of your process from getting software from version control all the way to the end user. So in essence, all the steps covered in the previous slides, and including this one. And I guess most of us, our pipeline will look something like this. With the various release teams, release engineers, development teams, DBA, and infrastructure folks working to push code out on a release weekend, with the release manager, as you can see sitting over here, orchestrating the entire process. Now, as you can already imagine and have experienced, this is a pretty huge human cost and burden, which is exactly why we want this process to be automated, providing feedback and continuous improved upon. Which brings us to our first difference between traditional CI/CD and CI/CD with Kubernetes, which is how the pipeline is automated. Now, if you've attended the previous tech talks or have experience with Kubernetes, you would have come across the concept of declarative versus imperative programming. Now, what you see on screen over here would be something similar to a traditional deployment pipeline with, say, a number of Tomcat, IIS, and our database components. And you'll see over here, this is the imperative process, which you need to define every single step on what needs to be done at what time in order to automate the process. So you see over here our release management server. So depending on what your release automation tool is like, we'll probably have to check out your package, prepare for deployment, set up the artifacts, and then update the configuration files. Then you start updating your application server, which means you got to say, okay, I got to copy this file from the WAR location, to back it up, uninstall the current release, copy the WAR file over, run this script to start the application. All the meantime, your database server also need to go through a number of steps as well. So this is the imperative process where you need to define every single step of the way. Whereas compare this with Kubernetes, which is more of a declarative deployment, the actual steps are being handled by the Kubernetes controller. And what we are specifying as release engineers, or as the release team, I should say, is the end state that you want to achieve. So you are actually declaring what the end state is. So as you can see over here, if we take a similar application over here, we've got another front end kind of a HTTP server, or maybe Nginx with a services back end over here along with the database component. Now, as you see over here, instead of specifying exactly what the steps are, what we're specifying here is For my front end, how many versions of my applications do I need? Maybe some of the limits I could put on resources. On my back end, exactly the same thing. How many versions, resources, and for my database. So this is our declarative pipeline, so to speak. And the thing with this as well, if you look back at our previous traditional deployment, typically we'll have a CMDB of some sorts just to kind of keep track of what version of the application we have and what server at what given time. Now with Kubernetes, that kind of goes away because when you deploy a version of your application, it is in the form of an image, which also is tagged with a version. So now when Kubernetes comes into play, all you need to do is look into your clusters through let's say an IDE tool of some sort. You see exactly what sort of workloads are being deployed on what node or what pod, right? So over here, you'll see I've got my Stacklight version 1.2.2 on this pod on a particular server, right? So this way, the role of CMDB is now centralized into your Kubernetes environment. So let's put this all together. What happens when code is being deployed, right? So at the very start, your developers would check in code to your source code management. Once that's done, the continuous integration process will take that code, build it, and create a container image from it. You store that into your image repository or a registry. Once it's in the registry, your security process will kick off. Scan the images for any vulnerabilities, match it against the database of known vulnerabilities and exposures to give you exactly what vulnerabilities there are, the severity of the vulnerabilities, and also remediation steps if available to ensure authenticity of your images. Now, to ensure that what you're deploying into your lower environments are the same as your higher environments, what you want to do is you want to promote your images rather than to essentially rebuild it in a higher environment. So this way you make sure that what you're testing in the lower environments is exactly the same thing as what you're deploying in the upper environments. So once you have that, your release orchestration process will then take that image by invoking the Kubernetes operators and the Kubernetes process, deploy them into your various environments. Now, at the same time, the operations folks and the infrastructure folks will make sure that you have an actual cluster to deploy to by using a multi-cloud management system to handle your container environments and your Kubernetes environments in the multiple, either on-prem or public cloud environments, right? Once it's deployed, now I want to make sure also that you could actually monitor your environments once it's in production. And this is where your monitoring solution will come into place, and making sure that it not only feeds back to your operation folks, but also to your developers. So this way you're shifting your monitoring left, and you're providing developers instant feedback on how their applications are performing the different environments. So this way performance tuning can be done much further ahead in the process and earlier, which reduces the cost of rework after the fact. So this is kind of your overall picture. And let's look at the application deployment process shown earlier. Okay, and we want to talk about the second difference between a traditional deployment and a Kubernetes deployment, which is the infrastructure side of things. So this, of course, is an abbreviated version of the process, and many teams that I speak to primarily focus on the application area. But if you look at the underlying activities that needs to support the process, is that there must, first of all, be infrastructure available to support and deploy the application code too, right? So the first thing we do is deploy your virtual machines onto some hardware, and maybe even before that, procure the hardware, which in this day and time is actually pretty hard to come across. Once you have that, then you need to install the dependencies onto your virtual or machines or bare metal machines. So for example, our Tomcat, we need to ensure we have the web servers installed, we got the databases installed, the right Java libraries, all that. So there's quite a lot of work to go through before you can actually deploy an application onto an environment. And with containerization and Kubernetes, the configuration process kind of goes away a little bit. However, the infrastructure provisioning is still relevant, because what you need to do is once your machine is provisioned, you also need to install your Kubernetes environment onto it. And if you want to take care of the other things such as networking and security, you got to look out for those as well, right? Make sure you have a standardized process or have something that's out of the box where it's all handled for you. Okay, so from before to now, we're just deploying that cluster onto the infrastructure, and then you're good to go throughout. There's no dependency installation because that's all handled in the containerization side of things. So one thing to look out for between the two. So how does that look like in practice? Here is a sample structure of what a Kubernetes deployment, a Kubernetes deployed application will probably look like. Okay, so what you have is, you notice not only your source code, but also your build and deploy declarations checked in along with the application source code. So the first part you see up here is your Kubernetes definitions, and this defines things such as, how many versions of a particular workload you want to deploy, where you want to deploy it to in the sense of environments, and we'll talk about that in a second, and any resource requirements that you have with these applications. Central to your application, of course, your application source code. That's being checked into the source code management as well. And so everything you see over here is checked into SCM, right? So make sure they're all version controlled. You can actually do code reviews like proper code. So everything is now centralized and everybody knows exactly where it's where. Thirdly, this is the build file, which takes your application codes and then builds it into the container images. And last but not least, your pipeline declaration. Now, in this case, we're using Jenkins, but of course, if you're using other deployment methods such as GitLab or even your GitOps processes such as Argo CD and such, you would include that into the source code management as well. And we'll see more of this in the next slide. And what you're seeing over here now is the deployment pipeline. So this is a simple Jenkins file that you'll check in along with your application source code, so you're not actually having someone declared in a central location. The developers now have flexibility on how things should be deployed, or maybe the developers will work with the release engineers and have that created and put into your repository. Okay, so I'll just point out some of the major important steps in here. Of course, there's going to be a lot more steps depending on what your deployment pipeline looks like. But first of all, after your code is checked out, we then simply build a container image. All right, we go ahead and give it a name and then also perhaps some versions or whatnot. You'll go through your unit tests and then you'll push that image into your registry. Okay, once it's in the registry, you notice it goes through a scan process and then signed for authenticity. And then here's the meat of our deployment pipeline, which is deploying your image into your environments. Now, deploying this into the environments is pretty straightforward. This one is a very simplistic method of deploying. It simply just calls the kube control using the files that we check in along with the application source code, right? And what we do is simply define what environment we want to deploy into using namespaces, and that's pretty much it, right? Everything else is defined in the file, and everybody could see what version, how many of which we need to deploy, all that is defined within the file. You can just simply open it up and then know all the details. Now, I really should talk a little bit about namespaces, and I guess that's part of a hidden difference between traditional CI/CD and Kubernetes CI/CD in that the concept of environment is slightly different between the two. Now, traditionally, when we say we have a test environment, a UAT environment, pre-prod staging, and production environment, they're usually segregated by networking and by a number of actual hardware boxes and so on, right? So physically, they are separate environments. Whereas when we work in Kubernetes, the lines kind of get blurred a little bit because you no longer necessarily have to use different boxes in order to segregate your test and UAT and so on environments, because we could do that through the concept of namespaces, and where that actually separates the different environments using configuration. There are obviously pros and cons to doing that. One of the pros is you now have more flexibility in your resource usage. I've got customers who are able to, if their UAT is not being used, essentially hijack some of that resource into their production environment for burst computing if there's any levels of high load. Testing can kind of stop a little bit, development can kind of slow down a little bit, and would just hijack all those resources and really beef up your production environment. And when that spike is over, release it back into the lower environment so that development and testing can continue. Right? So this way you have more efficient use of your resources. But I guess on the downside is you got to have a pretty good process of doing that. Otherwise, your production environment may also be impacted, right? So those are things to look out for when you're thinking about the concept of environments in Kubernetes. Let's talk about then what are some of the different ways of deploying application workloads into your environments using Kubernetes. Okay. So the first method is recreate. And essentially what that does is the Kubernetes operator will take your new version of your application. It'll simply wipe away all of the deployed versions that are currently out there and then just spin up new instances of your application. Upsides to that is it's relatively simple, right? Because you're simply just wiping out your application, you're putting a new one, your application state is entirely renewed, right? It's relatively quick, depending on on deployment, but the cons obviously is that you're now wiping out your entire environment, right? So the downtime it kind of depends on both the shutdown and the boot duration of the application. So there is definitely going to be a downtime of your application. So a method such as recreate will probably be best suited for your dev environment where developers would really just need, okay, I made a new change, I just want to test it out, let's wipe out the old version, let's bring in a new one, and so on and so forth, right? I would recommend strongly against putting this into a higher environment, your pre-prod or production environment, because you want to make sure you test out all the other processes. And of course, in your production, you definitely don't want downtime. So be careful with that. The second method is, it's kind of the default deployment method of Kubernetes, which is the rolling update. But by tweaking some of the parameters in the rolling update strategy, we can achieve what's called a ramped slow rollout, which means you're controlling the speed at which your new version is being deployed into your production environment to ensure that A, there's no downtime, and B, you're not flooding your system with the changes that is not ready yet. Okay, so the two parameters it really is the ones highlighted over here. Okay, the first one is max surge, which specifies the maximum number of pods the deployment is allowed to create at one time. Okay, so you can specify this as a whole number, like 2, as you see on the screen over here, or as a percentage of the total required number of pods. So example, 10% or 25%, and so on and so forth. And so by controlling that, you're controlling the number of new versions that you're creating at any given time to your production environment, right? So if I do a max surge with 2, you probably do something like this. When it's ready, then you actually start spinning up the other ones, okay? The second one, and a pretty important parameter, is the max unavailable parameter, which specifies the maximum number of pods that are allowed to be unavailable during the rollout, okay? So that means when you specify these two parameters in a ramp slow rollout, the maximum number of new pods that you're creating is 2. And until all these pods are available and up and running, it will not create any new ones, right? So this way, your version is slowly released across instances. It is pretty convenient for stateful applications as well that can handle rebalancing the data, because when you start deploying your new version, your data can then rebalance onto the new versions before you start deploying the new ones. And then when you have everything up and running as a new version, your data again is pretty stable and consistent throughout the different versions or the different instances of your application. Okay. The downsides to that is rollout and rollback would, of course, take some time, because you are actually controlling the number of new pods that can be created at any given time. So you're kind of throttling the deployment, right? If you're supporting multiple APIs, that's going to be a little bit difficult as well. And there's really no control over traffic, right? Once you deploy these 2 pods, you don't know who's going to go on it. So at any given time, some of your customers may be on version 2, whereas some may be on version 1. So these are things to look out for when you're doing your slow rollout methodology. Now the next one is probably familiar to all of us, which is your blue-green deployment. Now, to achieve the blue-green deployment, you notice over here on the screen, there are more definition YAML files than the previous ones, because a blue-green deployment is being achieved through really the use of your load balancing mechanism, right? In our case over here, I'm just going to use a Kubernetes service as our load balancer. It's not very sophisticated, but it kind of gets the point across. The blue-green deployment on a high level really is you manage two environments. You have a blue environment, which is your current environment. You have a green environment, which is where you're deploying to. And then once you're deployed to your green environment, you switch it over to green, and then and that's going to be your new production environment moving forward. Okay, so how we achieve that in Kubernetes is, here's my current instance. I've got my version 1 of my application, and I know I'm pointing to version 1 of the workload because in my service or in my load balancer, I'm pointing to a selector of version 1. Okay, so I'm only going to go to that. So my green deployment will happen by executing a deployment file of my version 2 application. Okay, that'll spin up the pods, deploy the workload, and have it ready in the background. Now, once you're ready, once you've gone through thorough testing of your green environment and you're ready to switch over, what you want to do is you want to update your load balancing, your service, to version 2 by essentially patching the service, right? I just change my selector to version 2. And what Kubernetes would do is it would now, instead of selecting version 1 of the workload, switch to version 2, and that's going to be your traffic moving forward. And once that's stable, then you could go ahead and take out your version 1, and now you have more compute resources to do as you need, right? That could be your new green environment or whatever. So the pros, of course, is in this case, you have an instant rollout and rollback, right? Because as you can see, it's a pretty instantaneous process. I just roll out to version 2, and that's it. If there's any issues, version 2 goes down, I just roll back to version 1 when it's still up, and it's, again, really quick process, right? The other benefit of this is you avoid your versioning issues because you're changing the entire cluster in one go. So you don't have customers on V1 or V2 and so on and so forth. Everybody's on the same spot. The downside to this, of course, is you realize that you have to manage double the resources, right? So you need a full proper production environment for your blue environment, and you need a full proper production environment for your green environment as well. You want to make sure you properly test the entire platform, and you want to make sure that's done before releasing to production. So everything needs to be tested thoroughly because you're essentially flipping the switch, right? And there's no real throttling of your environment. And because we're switching, doing a big bang switch, handling stateful applications could also be hard because what you need to do is before you switch to V2, that replication needs to happen between your version 1 and version 2 before you make the switch. Otherwise, your states will be out of sync. Okay, so those are some of the things to look out for when doing a blue-green deployment. Now, last but not least are Canary deployments. And this really is kind of well, I wouldn't say an alternative, but it's an improved and alternate version to your rolling updates and perhaps even your blue-green, in that what we're doing over here in a Canary deployment is we're making the new version of your application available to a select set of users. And that selection criteria could be region, it could be particular users, it could even be a set of accounts, right? Whatever the methodology you like to use. Typically, we see that where we release the new versions to kind of an early adopter set of customers who's really interested in finding out the forefront, the latest and greatest of application features. They're happy to test things out. They're happy to play around with things. They're okay when things break because then they found what can be improved. And you get this really quick and early feedback from the set of users, right? So that's definitely one of the pros of a Canary deployment. And it's pretty convenient for error rate and performance monitoring because then you can actually monitor in production. So you're actually testing in production fully at this point. And the rollback is pretty quick as well because now you just take one node away if we need it. Okay, so how we achieve that in Kubernetes is really through the actual deployment of the application. Okay, and in front of that, of course, there's probably going to be some more sophisticated logic needed depending on how you're going to release that to your customers. But on a very high level, this is what we do in a Canary deployment, right? We control the number of replicas for each of my versions. So I'm starting off with 3 copies of version 1 and 1 copy of version 2. And remember, you could actually set that as, well, you may have to do some calculations for percentages if you need to, okay? And then once you are good, I could then start ramping it up and I have 3 versions of my version 2 and 1 of my version 1. And then we're good with that as well, then I could actually go ahead and release it to all of them. So when you have multiple instances of this, you see that your release schedule is no longer linear as what we had before in our rolling updates. You can have it, kind of ramp up on a logarithmic scale if you need to, or kind of control it on your own. Now the downsides to this, as you can see, is the rollout is going to be a bit slower when compared to the other methodologies, right? Because you're now making sure that it's a very controlled rollout and it's a select set of customers when you're rolling out. And fine-tuning your traffic distribution could be expensive, right? So if you want it as single-digit percentages, you almost need essentially 100 pods and you start playing around with the pod numbers a little bit, right? But again, it kind of, on the plus side, it gives you that true capability of testing and production. So these are things to kind of balance out when you're thinking about these, right? And that is pretty much it. Hopefully this talk would have helped you a little bit in your journey on converting to or moving on to Kubernetes, how to integrate your Kubernetes environment into your deployment pipeline if you already have one, and some of the things to look out for when you're practicing Kubernetes CI/CD as opposed to traditional CI/CD. Okay? So if there's any questions, please let us know. Let's see how we can answer them on the spot or answer them as a follow-up. And that's pretty much it.